Hi, I'm Zhuohao Zhang, and today I'll be presenting our work CollabAlly, a system that aims to make collaboration awareness accessible in document editing. Here I also speak for my co-authors, Cheuk Phipson, Jaylin Herskovitz, JooYoung and Anhong. Collaborative document editing usually consists of understanding what other collaborators are doing in the document, reading and responding to comments, as well as tracking and making text edits. However, collaborative editing is challenging for blind users who usually lack the understanding of different visual cues in a document, struggle to navigate through different elements, and have very limited access to automatic real-time updates about the collaboration activities. To address these challenges, we conducted a co-design study with our blind co-author JooYoung to build CollabAlly upon a common collaborative editing tool, Google Docs. We co-designed CollabAlly over 3 sessions and achieved 2 primary goals: to understand the current practices and challenges that screen reader users have in collaborative editing, and to inform system iteration in the next stage. After iteration, CollabAlly uses a 3-layer model to first extract the state of the collaborative environment, second, identify and represent key collaboration activities in the environment, and finally, present it to blind users in an accessible and understandable manner. To extract a collaborative environment, we first fetch the DOM structure of the Google Docs using both a front-end browser extension and a back-end server. From there, we identify classes and HTML elements in the document that can be used to represent collaborators' behaviors, comment updates, and text changes. Finally, we present this information to blind users in real time using earcons, and design a dialog box interface through which blind users can navigate and access collaboration activities using keyboard shortcut and screen reader commands. We also incorporated spatial audio and voice fonts to further contextualize who, where, and when certain collaboration activities took place in the document. To demonstrate how CollabAlly works in a real-world scenario, our co-author JooYoung uses CollabAlly to review and edit one of our study materials. First, 2 collaborators showed up in the document at different locations.
Today, I'm going to go over the study material we used and resolve some comments. First of all, I wonder if there are any other collaborators on our team that are in the current document with me. Let me press Alt-Shift-1. In the dialog box, I'm going to press H key to go to the next heading. Collaborator summary here. There are 2 collaborators. First collaborator is Renee Jones. Let me click this by pressing spacebar.
Renee
I
Jones.
hear female voice font on my right.
Center of page 1.
I hear this spatial audio sound coming from my right. I understand this a little bit below from my current location.
Now a collaborator asks for suggestions by adding a new comment.
Oh, this earcon indicates somebody has just came to the same paragraph as mine. I wonder who that is. And oh, somebody has just left a comment. Let me check it out by pressing Alt-Shift-1. Let me press comments button. Here is comment summary on page 1. Oh, so she left this comment. So let me use blind people as a reply.
After reading the reply, other collaborators made text changes in the document.
I wonder what text changes have been made. So I'm gonna check it by pressing Alt-Shift-1. In the dialog box, I'll click text changes. In the text changes, dialog box, I'm going to press H key. There is only one text change and 3 style changes. The second change is about text modification from sense making to tracking of CollabAlly.
To evaluate CollabAlly, we ran a user study with 11 blind and low vision users who were unable to read any script. We asked participants to complete a series of collaborative editing tasks using either Google Docs accessibility settings or CollabAlly. The tasks included the 3 main collaboration activities we defined, which are locating collaborators, working with comments, identifying text changes, and one free form writing task, in which we asked participants to answer a few open-ended questions freely. 2 results from participants who used Google Docs confirmed our findings on blind people's current practices and challenges, and the other 9 results reported CollabAlly's usability. We asked participants to rate the level of easiness using CollabAlly to complete the tasks and helpfulness of CollabAlly's information provided after each task. And the results showed that most participants agreed or strongly agreed that it was easy to complete the editing tasks using CollabAlly, and the information provided in it was useful. From their feedback, we summarized the most liked features of CollabAlly, including deep integration with existing tool, easy navigation, sonification with spatial features, and fits into users' current workflow. We also summarized suggestions from participants. They wanted to have audio customization, direct copy and search navigation by clicking, and better integration with screen readers like NVDA and JAWS. In the next phase, we plan to better integrate our system with the current assistive technology ecosystem and extend it in different layers, including exploring other non-speech audios, build upon other screen readers, and consider other collaborative environments beyond document editing. Through our research, we demonstrate that CollabAlly provides improved access to collaboration awareness by centralizing scattered information, sonifying visual information, and simplifying complex operations. We envision that with CollabAlly, many existing collaborative editing tools can also be improved to provide better collaborative awareness and accessibility support for blind users. Thank you for listening.